Hi guys, it's Jen Yang, and today I'm going to talk about GCF and LCM as you can see here. And it wasn't like this when I first got the photo, but I added the dots so that it kind of looked like a Ferris wheel, kind of, so that you can tell it's kind of a Ferris wheel problem. Number 4. And we're having a summative assessment sometime this week or next week, something. And I just want to give a, kind of last minute explanation about this because it's kind of hard, it's confusing, but once you know it and once you know how to do it, it's really easy and it's really fun. Okay, so question number 4. You and your friend go to the carnival that has both large and a small Ferris wheel. You get on the large Ferris wheel, and your friend gets on the small Ferris wheel at the same time. How many seconds will pass before you and your friend are both at the bottom again if the large wheel takes 10 seconds to turn fully and the small wheel takes 4 seconds? Okay, so how are we going to solve this problem? Okay, so since we know that we're learning about LCM and GCF, which is the least common multiple or the lowest common multiple, and the greatest common factor. So how do we know if it's LCM or GCF? Because this is very hard to know. And okay, so here's an advice I want to tell you guys. It's that okay. So if it's a wheel or something turning or something when at the same time it's like, for example, not only the wheel problem, but like, so say John goes to swimming pool every Monday. Yeah, something like that. And then Jill goes to the swimming pool like on like two like Mondays and then Tuesdays and then and then when are they going to meet? And that kind of problems where you have the same thing together at one place and you have to find the first time they ever meet. Then you use LCM, which is this case. And for GCF, it's like kind of different-ish because it's like, so you'll see when you get the problems. It shows in the problem. It's not really LCM though. I think most of the problems that are given in math class is about LCM. So you can try that, or if you think that it's GCF, you can try that. Okay, so how do we know? Yeah, I just explained that. And how can we tell? Is you can like just about basically see like the problem, and then you can just read the problem and it will like come to you, or if it doesn't, you can like do more practices and then it's gonna finally come. You don't have to like really think about it. You just see it. You could say. So how do we do this now that we know it's an LCM question? Okay, that is a hard question. Okay, so I think what most of you are thinking is that we have to find the LCM of 4 and 10. And you are right. I mean, you are right. You're not like wrong or anything. Okay, so let's do this, baby. Okay, so in class we learned prime factorization. So if we wanted to do that right now, it would be 4 would be 2 and 2, and this would all be a prime number, so you don't have to do anymore. And then 10, they're both quite easy numbers. Divided 2 and 5, and they're all, prime numbers. Or you could do it this way, 10. This is, I figured this out, but I guess this way is better. And so that we don't have a lot of space. So we need to find the LCM of 4 and 10. We found out that 4 was 2 times 2, and 10 was 2 times 5. Well, 1 and 10, but let's not do that right now. Okay, so if we want to do a Venn diagram, so this is a Venn diagram, and that is 4, and that is 10, and that, my friends, is the LCM. So what we need to do is we can look at both of these, find what's in common. Like, what is in both of the numbers. So if you see here, there's a 2. I see a 2 because I'm not blind. And then there's a 2 over here too. Get it? It's punny. Anyways, it's not. Anyways, so since we have 2 in both of these, we write 2 here. I don't have any space. I just noticed. Anyways, and then I've already had 2 in there, so I write the other ones. 2 and 5. So, and then 2, my friends, would be the GCF, greatest common factor. And this all multiplied would be the LCM, which is 2 times 2 times 5, and which is 20. See, that is so easy. And like, one thing I want to advise to you is that you might think, how is this anyway related to the Ferris wheel problem? So I'll explain that. So say that this is a big Ferris wheel. I'm very bad at drawing, so please excuse my very bad drawing. And that is a small Ferris wheel. So this takes 10 seconds. That takes 4 seconds. So what we need to do is that these rotate, these rotate and like they rotate like again and again and again and again. And so does this, So this goes on and on too, And then you have to find time where, so let's say this is the point. And then you want this okay, so this is going to go, so this one is going to go more faster. This one's going to go more slower because it's bigger and this small. So this is going to go really fast. This is going to go like that. And what you need to do, you need to find a place where this meets at one point, and so does this. This meets at one point, this meets at one point. So that's why you use LCM, which we just find out is 20. So the answer would be 20 seconds. Wow. Yeah, okay. So, okay, yeah. Okay, and one last thing is that I want to explain you guys about the ladder method. So we watched a video about the ladder method in class, but I just wanted to review it. So, okay, so say we wanted to find the common factor. I mean, like least common multiple or the greatest common factor. You can find both of them. And, okay, so there's 2 ways to find that. One, which we already did, was a prime factorization tree. So how you do this is you take the number, so say the number is x, and divide it into other numbers, which one of them has to be prime, and then, has to be, and so y times z would be x. And then you can divide, or you can just stop here if both of those are prime, and then you go on and on and on and on until all of this x can be a prime number times prime, or how many of those you have. But right now we're not focusing on that. Okay, so what we're going to do is we're going to do the second method, which is the ladder method. So how you do this, it looks like a ladder, and it has an L. So say we wanted to find both the LCM and GCF of, well, say 12 and 30. So you draw a L. And what you're going to do here is that you're going to write the smallest factor, the prime factor that divides both of these numbers. So what do you think that is? Huh? So a prime number is like this: 2, 3, 5, 7. Oh yeah, I have not explained what a prime number is. Prime number, it only has two factors. 1 and itself. And what is a composite number? It's all numbers except the one that is not a prime number. So yeah, there we go. And then what we're gonna do now is that. Okay, so so what we're gonna write here is 2, I guess. So these are all prime numbers, and we're gonna try it from the least. So what is the least? Huh? Tell me. What is the least? It's 2. And it divides both of them. So I write 2 here, and I divide 12 by 2, write 6. 30 by 2, I write 15. And then I divide them again. What can 6 and 15 be divided by? The least one. Well, there we have it. 3. So I put 3 here. And then I divide 6 by 3, which is, yeah, tell me, blur it out, 2. And then 15 divided by 3, which is 5. Okay, there we go. Wow, nice job. That was really hard work. So we have to continue this until we have all the numbers that are prime. And to get the LCM, you have to multiply all numbers here, which is kind of annoying and long, but it is really awesome and it's really fun. 2 times 3 times 2 times 5, which is 60. See, I have good memorization. I'm kidding, okay? I'm kidding. And what you need to do for the GCF is that GCF, as you might have guessed, is a lot smaller than the LCM because this is a multiple. That's a factor. It has to be small. And you're going to be really surprised, and it is going to be, oh my gosh, multiply this. How awesome! GCF is 2 times 3, which is 6. How awesome! Okay, so I hope you enjoyed this video, and I hope you learned a lot about the ladder method and the GCF and the LCM, which is the important one. And I hope if you see this kind of question again, you can solve it. And yeah, thanks for watching my video.